Ever wondered what justifies a $500,000 price tag on a NASCAR engine? It's not magic, it's the culmination of advanced metallurgy, precision machining, and cutting-edge electronics. Today, we're peeling back the valve covers to reveal every high-performance secret hiding inside a 5,000 race-ready power plant. Buckle up, this is horsepower at its most extreme. Engine block and bottom end. At the heart of every NASCAR engine lies the billet aluminum block, a monolithic casting milled to tolerances of mere thousandths of an inch. This block houses a forged steel crankshaft, hand-polished to ensure perfect balance at 10,000 RPM. Each of the 4 steel H-beam connecting rods is ultrasonically inspected, and custom pistons, so crafted from aerospace-grade aluminum, are fitted with low-friction rings, cylinder heads, and valvetrain. Up top, you'll find CNC hoarded cylinder heads sporting 15 degrees wide-angle valve angles for optimal airflow. Each head features titanium intake and exhaust valves, light enough to float safely at redline speeds. The stainless steel springs are chatter-tested on a bench to prevent valve float, and the rockers are fully adjustable roller units, eliminating friction and maximizing valve lift. Fuel delivery and induction. Fuel is metered through an electronic fuel injection system rather than a carburetor, an innovation introduced in NASCAR's next-gen era. High-pressure injectors spray race-tuned Sunoco unleaded usaba directly into the intake ports, controlled by a standalone ECU. The intake manifold itself is a lightweight magnesium casting, tuned in the wind tunnel to boost volumetric efficiency at track speeds. Electronics and data systems. Beneath the hood's cosmetic covers lies a data-rich environment. The ECU records engine parameters 1,000 times per second, everything from NOx sensor readings to throttle position. Customized wiring harnesses tie into a driver programmable dash display and pit lane telemetry, allowing crews to make on-the-fly adjustments. Precision machining and assembly. None of this hardware performs without exacting assembly. Each engine is built on a vibration-isolated stand, where builders torque every fastener with calibrated pneumatic guns. Bore surfaces and journal clearances are measured with laser micrometers, and crankshaft end play is shimmed to spec. Every surface is deburred, aligned, and double-checked before pre-break-in. Dyno tuning and break-in. After assembly comes the dyno, where the engine is safely run through a strict break-in protocol. Crews monitor oil pressure, coolant temps, and exhaust gas temps, logging torque and horsepower curves at every 500 RPM increment. Software-controlled load banks simulate racetrack conditions, ensuring the engine hits 850-900 HP at 9,000 RPM reliably over a 500-mile run. Maintenance and overhaul. No NASCAR engine is set and forget. After just one race weekend, or roughly 1,000 miles, teams perform a complete teardown. Crank journals are magnafluxed for cracks, pistons measured for skirt wear, and valves lapped to fresh seats. Any part showing the slightest fatigue is replaced, and worn bearings are swapped out. The future of NASCAR engines. With hybrid systems and biofuels on the horizon, NASCAR's power plants are poised for another evolution. Prototype electric ANAS assist crank systems are already being tested, promising instant torque boosts. Meanwhile, additive manufactured, 3D printed components could soon reduce weight and improve heat dissipation. Cooling circuit innovations. Beyond the massive aluminum radiator and oil coolers, the coolest trick is the reverse flow water jacket. Unlike conventional blocks, the coolant enters at the hot end and exits at the coolest, reducing thermal gradients and minimizing block distortion. Teams also spray ethylene glycol mixtures chilled to just above freezing through high flow pumps, capable of 40 GPM, keeping cylinder head temperatures under 260 GF during green flag runs. Exhaust scavenging strategies. NASCAR teams prize the Tri-Y header design. 1178-ton primaries merge into 2 anaphores secondaries, then into a 3 anaphores collector, tuned so that pressure waves pull spent gases from the next cylinder just as its exhaust valve opens. This scavenging yields up to a 7% improvement in volumetric efficiency, translating to 50 to 60 HP without breaching RPM limits. Ignition and spark optimization. Gone are mechanical distributors. Today's next-gen engines use coil-on plug systems fed by a 250 amp alternator and a dual-channel ECU. Spark timing is mapped per cylinder, with knock sensors triggering real-time retards of up to 3 days to prevent detonation under full load. Jalopnik, lubrication and oil management. A dry sump system with 5 scavenger stages evacuates oil from the crankcase faster than 1,200 lm in, preventing windage losses and maintaining a consistent oil film on bearing journals, Wikipedia. Custom sump pans hold just 4 quarts, but external reservoirs store 12 quarts under inertial baffling to avoid aeration during high G cornering. Material science and coatings. Behind every piston and liner is a coating war. Ceramic thermal barriers on piston crowns reduce heat soak, while Nicocil plating on cylinder walls slashes friction by 30% compared to honed cast aluminum jalopnik. Valve seats are sintered with cobalt-based alloys to resist 1,500 DF exhaust temperatures for full race distance. Real-time telemetry and pit lane management. Every engine houses a black box module, sampling 50-plus parameters per millisecond and streaming via 5.8 GHz telemetry. Crew chiefs watch knock, AFR, air-fuel ratio, and coolant temp overlaid on live timing loops, making decisions on pit stops not by feel, but by data spikes. Season-long engine allocation rules. NASCAR limits teams to 5 engines per season, or 3 for playoffs. That means each power plant must last multiple tracks, some at 1.5 miles flats, some at asphalt short tracks, and even dirt at Bristol. Teams develop engine rotation maps, fresh engines at super speedways, suspect units at low-stress circuits. Cost breakdown and ROI. The $500 thousand sticker breaks down roughly as $120 $1,000 for the block and rotating assembly, $80 $1,000 for heads and valvetrain, $50 $1,000 for electronics and wiring, the $70 $1,000 for machining and tooling, $60 $1,000 for dyno calibration, $50 $1,000 for coatings and materials, and $70 $1,000 labor, plus sudden death build quality audits. Conclusion: beyond the checkered flag. From billet blocks and titanium valves to live telemetry and marathon dyno sessions, a $500,000 NASCAR engine represents the pinnacle of racing technology and human precision. It's more than metal and wire. It's the heartbeat of America's motorsport. If you're as fascinated by this engineering tour de force as we are, hit subscribe, ring that bell, and share your questions below. Which component surprised you the most? And what would you like us to unpack next? Until then, keep your engines tuned and your curiosity alive.